Go over a couple of things here. First of all, you read it from, it's just a kind of a story. We started to read it for meaning. And maybe some of you, I think, just drew a picture right away, which is fine. If I were to draw a picture, maybe I'd go ground, side of house, ladder. And I'd start labeling stuff. Maybe I don't know everything. Maybe I'd put the 25 right there. And then especially if I had already done that one that had the Pythagorean theorem, maybe I put like a B and an H right here. Because I know once this ladder starts moving, the B and the H will have to be variables because they're going to be changing the entire time. And maybe you don't put those B and H on there at the start. I don't know. Maybe that's all you do. And you go back and you say, all right, I've got this little picture based on my story. Now I am going to try to put a box around my objective. Did you guys put a box around this? Ooh, that's weird. Like I stopped writing, it's like behind me. There we go. Okay. What is the rate of change of the angle between the ladder and the ground? And of course, once you put that in a box, now what you've got to do is interpret that using some kind of calculus like variables. And now this is when you look back at your picture and maybe you realize, I don't have everything labeled that I need to have labeled, right? What do I need to label still? The angle, and I'm going to use a theta because that's what we use, but you could use really any letter to represent that. And it does say the angle between the ladder and the ground. So I'm going to put this right here, theta. So based on that, when you see what is the rate of change of the angle between the ladder and the ground, are you guys comfortable with me saying that I would interpret that as d theta dt? Rate of change of angle with respect to time? Okay. So I'm going to say equals, that's my objective. I don't know it yet. So stop and look at what you have. Any questions based on that? Okay. So then I'm going to look for other rates. So I see the base is pulled away at a rate of 2 feet per second. So just like before, someone's pulling the base away at a rate of 2 feet per second. That sounds a lot like dB dt to me. Based on my, you might have slightly different letters, but based on my picture, I hope that makes sense. Any questions? All right, and then dB dt specifically is 2 feet per second. That's a rate. I look for other rates, and in this case I don't see any other rates, and so I'm ready to move on. The last thing I'm going to mark in my question is the freeze frame moment. What is often the key word that we use or we look for? When. Yeah, so when the base is 15 feet from the house, there's my freeze frame moment. So I'm going to write freeze frame is when B equals 15. So this is a really important milestone to get to. If you pick this question apart, you've done most of the reading that you need to do. The rest of this is going to be math-like stuff. Excuse me, instead of English-like stuff.
Are we going to get to a point where we have lots of different rates we do in this?
I can't think of too many times when there's more than 2 or 3 at the most. We could probably find situations where there's 9 rates at play, but that just ends up taking forever. Okay. So I can think of one example where there was an unknown rate and 2 rates that played into that. But really often, at least directly, it's just 2 of them related. Okay. Sometimes there's 3, and sometimes the connection's a little bit different. But check your, I think there might be one in your extra practice that's sort of like that uses 3, but not directly, kind of. Yeah, you'll have to check it out. So picking out the name of the movie, right? The whole, what's the relating equation? Here's what you got to do. The whole point, or one of the whole points of this was, what we just did, is to help you with that. So I look up here, and I obviously, bless you, I clearly have a right triangle. It's right there. You can see it. And then I've got an angle within that triangle, and I've got a base. And, of course, I've got the hypotenuse and the height as well. What you're supposed to do is think about, what do I know about? And this, for all of you, this is in your past somewhere, very recent past, I think. What is some sort of a relationship that puts all those things together? And it's got to be a trig function, doesn't it? I mean, is there anything else that relates angles with sides of a triangle? Doesn't this just scream trigonometry? That makes sense? So don't get so bent out of shape about, oh my gosh, how am I going to figure it out? Look at the elements and just think to yourself, bless you, think, there's got to be something in my past that relates the sides of a right triangle or the sides with an angle or the area with something. It's there. It's there. I was talking with Kelsey a little bit, and I was explaining to her, like, I'm not going to ask you to do crazy stuff like what's the area formula for 1/3 of a sphere, and you're supposed to, like, somehow derive this symbolically. And, like, that's not going to be the thing. If it's really complicated, I'll just give it to you. Okay? I understand why you'd feel stressed about that, but realize that you do have it in your brain somewhere. Might take a little effort to get it out there, but it's in there somewhere. It really is. Okay, so you suggested cosine, right? Why did you suggest cosine?
Because you have to reduce it in the hypotenuse.
Yeah, right around that angle. That's exactly right. So let's try that. So cosine of theta equals b over 25. And I completely agree. It involves the theta, it involves the b, and it puts them together in an actual, understandable, clear way. We've picked out the name of the movie, but I think before we push play, I need to rearrange the pillows a tiny bit. A couple of folks were really bugged by this, and more than a couple of you did the quotient rule there. And actually, all the people that I saw that did the quotient rule did it really well, did it like correctly, the ones I saw at least. But you don't have to do the quotient rule. What you could do is you could write cosine of theta. I hope you're really paying close attention to this. Cosine of theta equals 1/25th b. Isn't 1/25th b the same thing as b divided by 25? And this turns it into a much easier looking thing where you could just use that really basic power rule idea to get this down to a simpler, when you're doing derivatives, a little bit simpler form. All right, so you guys ready to push play? What am I talking about? ddt. So I'm going to do ddt of everything. What is the derivative? Just what's the basic derivative of cosine? Negative sine. So ddt is going to be negative sine of theta times the chain rule factor, which is? You got it, d theta dt. Whoa, that's the thing we want. They just showed up as if by magic, but we know it's not magic. Equals, what is ddt of 1/25th b? Times the chain rule factor, db dt. Remember, the chain rule factor will never go away. We will always have to think of the chain rule factor. And in some cases, the chain rule factor is just 1, and so it doesn't really matter. In this case, obviously, it's not 1, so it does matter. Question?
Yeah, I'm just wondering, like, if you multiply the 25 over to the other side,
Yeah, you could do it.
does that leave 0? And then
No, what would be 0?
the derivative of 25?
No, because it would be a constant multiple, not a constant term. Are you good?
Yeah.
Okay. Anybody else? Okay, so we push play. Now it's time to, push pause at the key moment. We want to freeze frame this thing. So I know that dB dt is 2, so this equals, you guys okay if I just write 2/25ths? dB dt is 2, so 2 times 1/25th would be 2/25ths? Yeah? Okay. D theta dt, of course, that's the thing that I want. And then a lot of you got to this point. I'm really super proud. I think this is really an awesome place to be. If you got here or further is even better, of course. But it was like, wow, what am I supposed to do with theta at the freeze frame moment? Because, it'd be tempting to drop this 15 in there. But you got to admit, the 15 is not a theta. It's not an angle. So it'd be wrong to do that. But the theta has to be related to that b equals 15 somehow. Any ideas on what I could do to make this work out? Yeah.
You just use the original equation, like the cosine equals b over 25, and you plug in the 15 for b, and then you do like inverse cosine of 15 over 25.
I love that. That's a really cool math way of doing it, and I think that will work out just fine. Can I propose a slightly different way?
Yeah.
So what if your way will work. Please don't take this the wrong way. I just think there's a faster way. What if we redrew the triangle at the freeze frame moment? We know that the B and the H are constantly changing. What if we just redrew the triangle at the freeze frame moment? So it would look like this. This H is unknown. B is 15. The ladder is still 25 long. That's still theta. So wouldn't sine of that angle be H over 25? How on earth am I supposed to figure out that H? Pythagorean theorem. Or you could just remember from before that when the base is 15, the hypotenuse is 25, the height is 20. It's a 3, 4, 5. Yeah. So couldn't you say then, based on that sine of theta is 20/25ths at the freeze frame moment? That's the only time that'll be true. But at the freeze frame moment, which is what we care about, sine of theta is 20/25ths. So I would just say this is negative 20/25, which is exactly what Chance would have gotten if he would have done the inverse cosine and then just done the sine of that angle, right? And then just a matter of multiplying both sides by negative 25/20. So I'll just squeeze that in here and here. So nicely enough, the 25s cancel out, and I get negative 1/10. The 2/20. Yeah? Did anybody take it all the way there? Anybody get all the way home to 1/10? Negative 1/10? Oh, sorry. I wish you would have. There was quite a few folks that I saw that got to like here, and they're like, what do I do with sine of theta? I thought that was pretty good. Really did. Suggestions on units. For once, it's not feet per whatever, feet per second. Not degrees. What's the only other way you've learned how to measure an angle? Radians, yeah. It's radians per second. Oops. Radians per second. Radians are what just naturally show up. You actually have to force fit degrees. Degrees are really inconvenient. So radians are actually the more convenient unit. So. Okay. So just do like a brief self-reflection. How far did you get? How many points you think you would have gotten if that were a quiz question?
Like one.
Okay. All I'm asking you to be honest, you're not a finished product yet, right? We got to keep working at this. You guys have any follow-up questions? I was really pleased walking around, just watching what you had, Kayvon.
So after you find h equals 20, can you go through the rest? Of
Yeah.
what you
So
did there?
how I got the 20/25?
Yes.
Yeah. So sine of whatever angle is equal to opposite over hypotenuse from the SOHCAHTOA fame. So what I just did is from my theta angle, I said my opposite is 20 and my hypotenuse is 25. And then drop that in for sine of theta, but it was already negative sine of theta, which made the end result negative 20/25.
Okay.
Does that make sense?
Yes. And where do you get when you multiplied it by the inverse?
I multiplied by the reciprocal because I was trying to get the d theta dt by itself.
Okay.
The way that you can get rid of a factor that's a fraction is you multiply by the reciprocal. Multiply both sides by the reciprocal.
Awesome. That makes sense. Thank you.
Okay, you bet. Anybody else? There's no question too little or whatever. Yeah, Chance.
So like I did it in like a different way, but like would I get credit for like the way that I did it?
You're talking about the whole sine and cosine thing?
Yeah. I just
Sure.
did, like, the angles and-
Oh, yeah, totally. So, I think you did, let me see if I can predict what you did, because I think what you did is probably really good. At least what you said at the start was really good. You said that you started here, and you said cosine of theta at the freeze frame moment is 15/25, right?
Yep.
Now, did you use your calculator?
I used my calculator to do the inverse cosine.
You don't even actually have to do that.
Really?
You could rebuild the triangle based on this, but I suppose if you want to use your calculator, it's fine. So you're saying theta equals inverse cosine of 15/25.
Yeah.
And what you could do is, as long as you're in radian mode, you could figure out you could use the calculator to estimate the inverse cosine of 15/25, and then just go sine of previous answer, right?
Yeah.
And that should give you apparently negative 20/25, or 20/25 perhaps. Yeah, and that's totally fine. And I don't know if this would be a calculator active question or not. I don't know. It probably would be. I don't know. It's hard to say.
So that would count as an answer as well during that?
Oh, you
Well, did you get negative 0.1 for a final answer?
Yeah, I got negative 1.
Oh yeah, like his way is totally legitimate. But my question was, if the calculator is active, his way is totally fine. If the calculator is not active, you're sort of stuck. That way, but my way, you just build the triangle at the freeze frame moment, and just go opposite over hypotenuse. So that would be very doable without. I think it'd be good to know how to do both ways. Anybody else? Question, comments, concerns? Gretchen?
Will there ever be one with three variables in it?
I can think of one like that. I can think of ones where I've seen where you've got a circle and a radius and a diameter and a circumference, all of which are changing, and you got to figure out how to relate all those together. I can think of another one in which it was a really weird one. It was an AP question where like an oil tanker is leaking, and it's creating like this cylindrical looking oil slick in the ocean, and there was 3 different rates acting, one of which you wanted to know, 2 of which you either knew or had to figure out, that kind of thing. So it's very possible. Listen, let's just be honest. You guys are like baby birds at this still, right? You're just barely getting out of the nest, and so we just got to keep building it. Yeah. Okay. Let's go ahead and take a peek at some others. I think we just got a couple of them left. We did that one. We did that one. We did that one. Yep, we got the tank and the distance. Would you? Yeah. So, guys, will you please turn to number 1? Turn to number 1. Bless you. And key rates, some of which are really obvious, some of which are not. And see if you can get as far as you can, give you a few minutes here, and I hope it works out awesome. We'll see. I'll be around. Ready to go. Of the distance. And so as I start to read this over, I am definitely going to put a box around that. Find the rate of change of the distance. And, you could say between the functions, I suppose, something like that. So as far as how I'm supposed to interpret that, I think we need to go to our picture, maybe do a little bit of labeling. Here would be my proposal to you. I am going to label the distance between the 2 functions with simply a vertical line segment. The reason why I'm going to do that is because the shortest distance between any 2 objects is always a straight line. And specifically in this case, it's got to be a vertical line, because if it has any angle to it, that will not be the actual distance. It'll be some bigger number than the actual distance. I'm going to label that with the letter D. You could label it with a Y or an H or something. I'm going to label it with a capital letter D for distance. Make sense? So I'm going to now say that the objective for me is d, d, dt. That's my unknown. d, d, dt. I'm then going to go through and look for more rates. And I see one right here. It's not super clear, but it does say dx dt. That automatically makes it a rate with respect to time. So I'm going to say then that dx dt is equal to 2. I'm just going to essentially repeat that, but pull it out as a key feature of what I need to do. I do not see any other rates, but I do see a freeze frame moment, which is when x equals 1. So freeze frame moment when x equals 1. So I think everybody that I walked around, I didn't get to every single person, but I think just about everybody had something like that. Maybe some different letters, but we had those concepts down, so that's great. This next part sometimes is the challenge. I am not going to lie to you. You might actually have to really wrestle with this, and you might have to fail a couple times before you succeed, and that is okay. As long as you keep at it and you keep trying, you will definitely start to pick this up. So the way that I like to think about this is, more than one person suggested the distance formula, and that will work just fine. The thing about the distance formula is there's no delta x on my vertical line, is there? Delta x is just 0. So think about this. I'm going to erase this. If I thought about this like a distance formula, if I said distance is equal to the square root, it's essentially delta y squared minus delta x squared. Isn't that the distance formula? Well, based on my picture, isn't delta x 0? And so distance would then equal square root of delta y squared minus 0. And that's just square root of delta y squared. And what's the square root of delta y squared?
Delta y.
Plus or minus delta y. You could make square root's already in there. But yeah, we would just say distance equals delta y. And what's delta y? Oh, no. Just in general, like what is the meaning of delta y? Change in y.
Oh, we could find that out just by plugging x in.
We'll get there. Come on, what's delta y? This is we're going to come back around to
y1 minus y2
y2 final y minus initial y. Right? Remember from the slope formula, like y2 minus y1 over x2 minus x1. That's all delta y is. And so I say all that to say, if you want to go through that whole distance formula routine, you are welcome to it. I don't think that you have to at all. I think what you could do is at the very start say there is no left or right differential between the distance here. It's all about up and down. And so I would say my distance equals one of the y's minus the other y. What do you guys think would be the wiser y to make the y2? Like, what would be smarter? Which one would be like the one that comes first? Blue. Agreed. Why would blue go first?
Because it's bigger.
It's higher. For at least for our whole domain, it's higher. So I would say distance equals, the blue is the cubic, so it'd be x cubed plus 6x squared minus 3x plus 1 minus the other one, which was sine of x squared. Okay. That's your movie. Again, you just need experience. Please hear me out. I'm not expecting you to be perfect here because you just don't have enough experience yet to be perfect. But if you keep working and you show up ready to roll next week and you do your WebAssign, I think you got a good shot. I really do. But if you do nothing between now and then of substance, you don't have a good shot. Make sense? You got to keep at it. You got to keep wrestling, keep working. All right. So there's the movie. We got to push play, though. How do we push play? DDT. So you're right. So DDT of everything. So what's DDT of D?
DXT or DDT.
DDT. It's kind of hard to say. There's a lot of D's. Okay, so then let's run through this. Most of this is just a power rule. What's DDT of x cubed?
3x squared.
3x squared times?
DXDT.
Very true. All of these are going to have a dxdt on them, aren't they? So if we wanted to, we could just factor it out mentally, but let's put them all in there for now. What about DDT of 6x squared? 12x dxdt. What about the DDT of minus 3x? Minus 3 dx dt. And then finally, I'm going to have to squeeze this under the graph. What is just the basic rate of change of sine? Cosine. So it's going to be minus cosine of x squared. But then I'm going to have a pretty involved chain rule factor. 2x times dx dt. Sorry that I'm kind of going downhill on that little slope. I just wanted to miss the graph. Okay, so what's the good news here? Don't we have everything?
Just plug DXDT.
It's like we got all the dxdt's, but we know what that is. I know the freeze frame moment is when x equals 1. There's no tricky inputs here like on some of those others. It's just wherever you see an x, put a 1. Wherever you see a dxdt, you put a 2. So I'm going to say my final dt. Let's see here. It's going to be 12. Yeah. No, it's 3 times 1, so it's 6. Yep. Plus 24 minus 6 minus cosine of 4 times 2 times 2. Right?
X is 1, so it's just cosine of 1.
Oh, darn it, you're right. Sorry about that. It's cosine of 1. You put the 1s where they go and the 2s where they go and try not to mess up like I just did. I'm trying to go a little too fast, and that's what happens. Cosine of 1. I think I got the rest of those in there. Okay, so this is where the calculator has to be used, right? What's cosine of 1? I have no idea. Neither do you. Let's go. Basically, it's 24 minus 4 cosine of 1 in the end. Kayvon, your question. Please, somebody calculate that. Go ahead.
Why isn't there a dxdt after the cosine squared?
So the derivative of just like the rate of change of simply cosine is negative sine. Or sorry, the derivative of sine is cosine. That's it. So the only time you're going to get a dx dt is if you're differentiating with respect to time, specifically an x. And we didn't get to the x until we got to the inside of that. Everybody got it? 24 minus 4 cosine of 1?
12.
12 something? Please do in radians. 24 minus 4 times cosine of uno. Meg, you got it?
Like the whole thing.
I just want a decimal answer.
18.83.
Can we get anybody to confirm that to be sure? 18.839. If in the next 10 seconds nobody confirms it, we're just going to assume that Meg got it. We're moving on.
Wait, what's the 24 minus cosine of 1?
Yeah, I'm saying that the 6's add out, giving me 24.
24 minus cosine of 1 times 2 times.
I got 20.
Yeah, so 2 times 2 is 4, so 4.
20.0.
It's 21.83.
21.3 zeros.
20.
Oh, 20 point. Oh, they're getting 20.83.
I'm getting 21.8.
21.83.
I put it in right. 24 minus cosine.
Are you in degrees?
Are you in, who's in radians or degrees?
I'm in radians. I'm in degrees.
It has to be in radians. Radians is what we live in this class.
So that means 21.8.
21.83 what?
21.83879.
So 21.839? Okay. Oh, so that's weird, Meg. So
I think I messed up.
you had the right decimals there on the end. 839. Okay. Hey, thank you. Any questions?
What's the unit on that?
That's a really wonderful question. We were not given any time unit, and we weren't really given any kind of a linear unit. And so, unlike all the other ones we're going to do, I just leave this one unitless. Please don't make up like the ubiquitous units per second or something like that, because we just don't know. So if there's no units given, don't worry about it. Most of them will have units, but this one just did. Okay, we got one last one to do. We're going to do this one together. So if you guys would turn to the soon-to-be famous cone problem. All right. So this is a more challenging version of a question that showed up in an AP test years ago. Hear me out. It is a more challenging format than what the AP students saw. So we're just going to explore a little bit with this one. Let's read it for meaning. I'll read it out loud. It says, a conical tank with vertex down. Can you picture it? Conical tank with vertex, the pointy part down? Okay. 10 feet across, 12 feet deep. If water is flowing into that tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. So, 6-year-old version of this story, what do we got?
Water's filling a tank.
Water's filling a tank, and what's happening to the water level in the tank? It's going up, which you would expect, right? Unless the tank is leaking faster than the water's flowing in. So, does this feel like something we should draw a picture of? I concur. I think we definitely should draw a picture of this. Here's going to be my best effort. I'm going to try to do this in one shot. There's the top, and there's the vertex pointing down. I've done better, but I'm going to live with that one. I think you're right. Not too bad. Okay, so I am told that tank is 10 feet across. So I'm going to just maybe put a little label on here, just filling out the story here. And it's 12 feet deep, so I'll put that over here. And I know that there's water in there. I have the luxury of having colors. So I'm going to put a little water in here. Like so. There's my partially filled tank. And I know that water is flowing in, filling up the tank more and more. Okay. So let's read here, and let's start reading for meaning as far as what we're supposed to find. Anybody see what we should be putting a box around here? Find the rate of change of the depth of the water. That's exactly right, Julia. So here's my box around that part. And now I look back at my picture and I realize I got to label a little bit more here, right? Because I don't have the depth of the water labeled, do I? Robbie, question.
I'm just confusion about what is depth of water. Is that like a volume?
Depth. No, if I said that I jumped into the high dive or jumped into the deep end of the pool like you did when you were a little kid, I jumped into the deep end, and I said the deep end has 90 gallons, wouldn't you be like, yeah, but how deep is it? And I'd be like, oh, yeah, it's 12 feet deep. So we're talking about a linear unit. Good question. We got to keep that straight because we're also going to have volume in here too. Okay, so I'm going to say that is my depth of water. So I'm going to call that, I don't know, D for depth. Something like that. Does anybody see any other rates that might matter? Oh, sorry. What would be the symbolic meaning or the symbolic interpretation of that? dd dt. Yeah, so like the rate of change of depth. So that's our objective, dd dt. Now, does anybody see any other rates that might play into this? Kayvon? Yeah.
The rate of filling is 10 cubic feet per minute.
Yeah, the rate of filling. Now, this is where it's going to get a little tricky, where I think units are going to matter. So it says, the water is flowing into the tank at a rate of 10 cubic feet per minute. So when you see cubic feet, what do you have to think of? Volume, right? Cubic feet. So this is in lieu of gallons, right? It's cubic feet. So we're talking about volume. So when we say the water is flowing in at a rate of 10 cubic feet per minute, symbolically, I think there's one thing that makes sense. It's the rate of change of volume. So how about dV? V as in Victor, dV dt. Does that make sense? V for volume. And that would be equal to, should it be positive 10 or negative 10? Why?
It's adding.
Yeah, it's making the amount of water go up. It's increasing, for sure. Freeze frame moment.
80 feet deep.
That's right. So when D equals 8, that's not a distraction, is it? Is that about calculus? Then it's a distraction. Okay. So we got to pick our movie out, friends. We're going to watch a movie about this tank getting filled up with water. I've got a depth. I've got a volume of a conical tank thing. Any ideas? I would not necessarily expect you just to pull this out of the air. Maybe you could. Volume of a cone, agreed. That's actually it. Does anybody know what that is? Close. It's 1/3. So it's volume equals 1/3 times what? Well, yeah, but it's a circle, so circular base. Pi r squared times the depth. So I'll put D for depth. Typically it's pi r squared times h for height, but D, same thing. Depth, height, same deal. Okay, so guys, hey, listen up. Hey, this finish is intense. Well, once we get something done here, it'll finish easy, but the finish is intense. I want you to think one step ahead here. This is something I'd normally give you. I want you to think about this. If I were just to push play right now, would you guys agree with me that if I pushed play, wouldn't I get a dV dt somewhere in there? Is that okay?
Yeah.
That's more than okay. Isn't that what I want? And again, if I were to push ddt, if I were to push play here, wouldn't I get a dr dt in there somewhere?
Yeah.
Is that okay with you?
No. We could just plug in 5 to R.
That's actually, well, hold on. We're going to talk about that here in a second. But isn't dr dt something that we don't know and we also don't care about it? Would we also not get a dd dt? And that's something we want, right? So the R is the problem, right? We can't have anything having to do with R in this. So here's what we do. I'm going to spare you, since we're down to our last 3-4 minutes, I'm going to spare you the jumping through hoops. We need to use a little geometry. Have you ever thought of a cone as basically being like a 3-dimensional triangle? That's all it really is, if it's spun around a kind of a circular pattern. So what I'm going to encourage you guys to do is think about this. Doesn't the cone of water have a radius as well? And just like the depth, isn't the depth going to be constantly changing? Won't the radius be getting bigger as well? So I'm going to label this with an R. Does anybody see the relationship between the little tiny triangle of water and the big triangle of the tank? Similar triangles. Yes? So check this out. I can actually use this idea of similar triangles to reduce my number of variables and make this easier. So what I'm going to say is this. I hope this makes sense. 5 is to 12 as R is to D. Why would I use a 5 instead of a 10? Diameter is 10. That's right. Diameter is 10. I want my radius. 5 is to 12 as R is to D. Remember, I don't want the R. Remember, R was causing issues for me? So I want to solve this for R. It will look like this. 5/12 D equals R. And then can't I simply replace the R with 5/12 D? Just based on the shape of the tank. I do want to let you know that on the AP test, and I think something I would probably do, I would probably give you that relationship. I'm not going to expect you just to come up with that on the fly if I ever ask you a question like this. Okay, so here's my replacement. Volume equals 1/3 pi times 5/12 R squared. Yeah, 5/12 D squared, sorry. Times D. So all I've done is I've replaced the R with 5/12 D. You're going to see here, we only have about a little bit less than a minute left, but you're going to see this finish quickly. So volume equals 1/3 times pi times 25 1/44, right? 5/12 squared. You guys good? 5 squared is 25, 12 squared is 144. D squared is D squared, but then times another D is D cubed, isn't it? Meg, your question?
Like, why wouldn't we just do 2 times 1/3 times pi? Oh, wait, is
Two,
that
where'd the
like-
2 come from?
Or what, because, like, it's squared.
Well, I haven't done any differentiating yet.
Never mind.
Okay. So now I'm going to do a derivative really quick. We do ddt of everything. What's ddt of v? That's what I wanted. Sometimes it's hard to realize this, but aren't all 3 of these just constant multiples? Pi is a constant, 25 1/44, 1/3, they're all constants. So it would just simply be 3 times 1/3 times pi times 25 1/44 d squared times, it's my chain rule factor. I apologize, I'm keeping you a little bit late. What is it? d dt. So here's how this finishes. Do we know what d is at the freeze frame moment? It's 8. Do I know d dt? Do I know dv dt? I just got to plug stuff in. I'm going to leave it at this. I want to get you guys out of here on as close to on time as I can. Plug the 10 in there. The 3 and the 1/3 canceled. So just be pi times 25 1/44 times 8 squared times dd dt. And as long as you can divide both sides correctly, you're going to get what dd dt is in feet per minute. I tried to time that right. It gave you a little too much time at the start. I thought I had it. Okay. Hope you guys have a great weekend. Practice, 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 okay? You need lots of practicing.
Do you know how long this website is? Is it a long one or is it?
I don't know. You're talking about like number of questions or time or both?
Probably number of questions. Like, is it just like, it's not that big.
Is it a